Hello, my fellow number people. Welcome back to my channel, and today we're going to talk about writing equations from graphs. This is a remedial video, so I'm not gonna go into detail of each of the graph, but we are going to combine all three graphs together and come up with the equations. And we'll be looking at linear graphs and the equation, parabola and the equation, and regions from inequalities. Okay, let's get into it. Here is a question from an old exam booklet. I think it's 2022 and 21 paper combined. So I have a parabola here and a straight line, and we'll start with, okay, we'll go by the questions that come in the paper. So the first one is find the coordinates of the x-intercept of the straight line. So we are focusing on the straight line linear graph here, and the x-intercept is the point on the x-axis where the straight line passes or cuts through, and that's this point right here. And as you can see, the x coordinate is +1 and the y coordinate is 0. So here is the answer to the first question. The coordinates for the x-intercept are 1, 0, and they must be put in brackets. Coordinates must always be put in brackets. If you don't put them in brackets, your answer will be wrong. Okay, part B, write the equation of the straight line. So again, we are focusing on the straight linear graph. Okay, the standard equation of a straight line graph comes in this form: y equals mx plus c. M and c are numbers. M is the gradient or the slope of the graph, and it will be negative if the graph decreases down. If we go from left to right and the graph decreases down like this, the gradient will be negative. If the graph increases as we go from left to right, then it will be positive. Okay, this c here, the constant number, is the y-intercept. More specifically, it is the y coordinate of the y-intercept. That is the point on the y-axis where the straight line cuts, but it is especially the y coordinate. Alright, take note, the gradient is the coefficient of x. It is always written in front of x. It is multiplied by x. So we only need these two things to find, and then we'll substitute back into the standard form, and that's it. We have our equation for the straight line. So let's start with the y-intercept, which is the easiest to find since we can only get it from the graph. So the y-intercept is the c value. Again, it's specifically the y coordinate of the y-intercept. So as you can see from the graph, it is a +2. Okay, next thing is the gradient, the m. So from the graph, sometimes you can use a formula, y2 minus y1, x2 minus x1, if the coordinates are given, or if you don't want to find the coordinates and then use the formula, you can simply go rise over run. So m is equals to rise over run. In order to rise, you have to first start at the point that is at the bottom, and then you run. So in order to find this, we have to pick 2 points on the graph, and take note the 2 points must be nice points. What do I mean by nice points? I mean they are coordinates must be whole numbers, because no one wants to deal with fractions and decimals. So this point right here is a nice point since the coordinates are whole numbers, and this point is also a nice point since the coordinates are also whole numbers. So we are going to use these 2 points, the x-intercept and the y-intercept, to calculate our gradient. So first, rise from the bottom point, we rise up and we count the number of units that we go, 1, 2, and since we are going up is a positive movement, so it's a +2, +2. Run. Now when we are running towards the left to the second point, and left means negative movement, and we are going from 1 to 0, so it's a 1 step movement, so it's -1. And +2 dividing by -1 is -2. So we have our m and our c. We're just going to substitute. So we're just going to substitute c in place of c with the sign, and m in place of m with the sign. And this is our equation. Y equals -2x plus 2. -2x plus 2. Take note, when you write your equation, make sure you line it up nicely in the standard form. The letter must come first with the gradient, and then the constant number comes after. Okay, next we'll be looking at the here is question C. Write the equation of the parabola, and the parabola is this graph right here. So before we go into the equation, take note, previously we learned about solving quadratic equation. Okay, going back, remember when we were solving quadratic equation? So this is what we did when we were solving quadratic equations. First we equate to 0, so we make y become 0. Then we factorize. So to factorize, we find 2 numbers that multiply to give the c value. The c value in our equation, which is the constant, -3. And those 2 same numbers must add to give the b value, which is the coefficient of x. So if we think about those numbers, the bigger number must be positive, because when they add, the sum takes the sign of the larger number. So 2 factors of 3 that add to give a +2 will be +3 and -1. So those 2 same factors of 3 that multiply to give -3 and add to give +2 are +3 and -1. So these 2 numbers will now be part of our factors. Okay, so we have 0. Okay, so these 2 numbers make up our factors. X plus 3 is one factor and x minus 1 is the other factor. Then the next thing we do is we solve for x, and in order to do that, we are going to separate these 2 factors and make them equal to 0. So So we separate these two vectors and we make them equal to 0, and then we solve. Now, why do we equate these vectors to 0? Well, it comes from the fact that if you multiply anything with a 0, you always get a 0. So we are assuming that each of these vector is a 0, since when they multiply together, we have a 0, and that is why we equate its vector to 0. So x plus 3 equals 0. In order to solve for x, we carry out opposite operations to go from left to right, which are opposite positions across the equal sign. Okay, and this gives us x1 value as -3, and x2 we have x minus 1. So to move it to the other side, we plus 1 on both sides, and therefore x2 is a positive 1. Now, these values are just called values when we only solve the equations. If we were going to draw the graphs, if we were going to draw the graph for this quadratic equation, then these two values are our x-intercepts, meaning they are the points on the x-axis, -3 and +1. They are the points on the x-axis where the parabola will come and cut. Okay, so here is a rough draft of the graph of this quadratic equation. Okay, take note, these solutions, the solutions or the values of x, they are actually the x-intercepts of the graphs. Okay, they are the x-intercept of the graph of the particular equation. So keeping that in mind, now in order to come up with the equation, of the graph, we are going to go backwards in this process. Okay, we are going to find the x-intercepts, we are going to put it into the vectors, and then we are going to expand the vectors to come up with our equation. Okay, so let's get going. Here is the vector form of the quadratic equation, and take note, this here is the standard form. That's the standard form. Remember, when we were trying to solve, we started with the standard form. Right here, and then we ended up with the vector form, and then we solved. Okay, so that's how we're going to do it. First, we are going reverse. So first we get the x-intercept, we put it in the vector form first, and then we vectorize into the standard form. Okay, here is the general vector form of a quadratic equation. Y equals a x minus b times x minus c. Okay, this b and the c here, they are the x-intercepts. They make a part of the vectors from which we solved before and get our x-intercepts or x values. So we find the x-intercept by looking at the graph. So looking at the graph, one x-intercept is -3 and the other x-intercept is 1. Okay, x1 is -3, x2 is 1. So we plug these values in place of b and c. Now take note, the factor form of the equation has x minus b. So if the x-intercept is a negative number, you do not use this minus sign and say that's the sign of that -3 here. No, you don't. You bring this sign down and you bring the x-intercept with its own sign. So we'll have x minus -3. And here x minus c, x minus 1. Okay, we'll simplify this bit. X minus -3. In directed number, the rule is we add the opposite of the second term. So x plus +3 is x plus 3. And at this point now, our equation is half complete and it's in the factor form. Okay, so as you can see, we have y, a, x. We have 3 variables here, and we need to find one of them, which is the a. Okay, because our standard form of the equation is y equals ax squared plus bx plus c. We need a and b and c to be known. At the moment, we only know b and c already, so we have to find a. That means we have to know the value of x and y in order to substitute and find a. Okay, to do that, we are going to find a point from the graph where we will get the x coordinate and the y coordinate of that point to substitute in place of x and y. So let's go back to the graph. Take note, we don't go back and get the x-intercepts because they are already used. They are plugged into the equation already. We can pick another point on the graph so long as it's a nice point where the coordinates are whole numbers. This point is not nice because the x coordinate is not a whole number. This point also, this point is a nice one. The x coordinate is 0 and the y coordinate is -3. This point is also nice. The x coordinate is -1 and the y coordinate is -4. Okay, so you pick a point that is nice, having whole number coordinates, and substitute in place of x and y. Now for our case here, we pick the turning point, which is the turning point, which is this point right here, where the x coordinate is -1 and the y coordinate is -4. So we substitute in. X is -4, so it goes in place of x. X is -1, so it goes in place of x, -1, and another x here, -1. Y is -4, so it goes in place of y. Y is -4. And we calculate now to solve for a. So inside the first bracket, -1 plus 3 is a +2. -1 minus 1 is -1 plus -1, according to directed number rules, which gives us a -2. So 2 times -2 is a -4. And in order to find a, since a is multiplied by -4, we divide both sides by -4, and so a is +1. And now we know all the letters in the equation. We know a, and we know b, and we know c. So our equation is almost complete. We plug in a value, which is 1, in place of a, and everything is done now. The last thing we have to do is we have to expand these brackets and we'll get this equation from the vector form to standard form. Okay, right now it is in the vector form, and we do not want that unless the instruction asks us to leave us the equation in the vector form. If they just ask you to write the equation, they're expecting you to write your equation in the standard form, where the letters are in alphabetical order. The variables x, they come in order of their power, the one with the biggest power first, followed by the one with the smaller power, and so forth. So ax squared plus bx plus c. Okay, we are now in the vector form, so let's expand. 1 times x is x, and 1 times 3 is 3. And then the result of this first multiplication is again multiplied by the second bracket. So x times x is x squared. X times negative 1 is negative x. 3 times x is positive 3x. And 3 times negative 1 is negative 3. And then we collect like terms. We have x and x here. So negative x plus 3x, directed number rule says you subtract the 2 and put down the sign of the larger number. So 3 minus 1 here, 1 is the coefficient of this x. 3x minus 1x is 2x, positive 2x. And this is our equation, y equals x squared plus 2x minus 3. Okay, just to confirm, the constant here, c, shows the y-intercept, again the y-coordinate of the y-intercept. So let's just check with our graph to confirm. The parabola cuts the y-axis at negative 3, so we are good. Another check. The coefficient of x, which is the a value, also tells us something about the graph. If it is positive, the graph will open upwards, and if it's negative, positive a, if it's negative, then the graph will open downwards, or it will continue to extend downwards. Now, since our a value is a positive 1, we expect our graph to extend or open upwards. Let's check to confirm. Yes, the graph is opening upwards. Okay, that's it. This is the equation of our parabola in standard form. Let's move on. Now we see regions with inequality graphs. And the graphs of inequality, they form from a straight line and a shaded region on one side of the line. So what we are going to do is, first we're going to find the equation of the straight line, and then we'll decide on the shaded region part. Okay, inequalities, they deal with these symbols: greater than, less than, greater than or equal to, less than or equal to, and their solutions are not just one single number. It is a range of numbers, and so they are signified by the shaded region on one side of the straight line graph. So here's how we're going to come up with the equation if the graphs are given. Let's start with this first graph, graph A. Here we see a straight line passing through the x-axis of positive 3 at positive 3. So step 1, we find the equation of the straight line. Take note, equation. Since the straight line is vertical and there's no slope, there's no gradient to it, it only passes through the x-axis at positive 3, and so its equation is x is 3. Step 2. Now we look at the region in order to decide which one of these 4 signs will be in our inequality. So 2 things to look at. First, the region. Which side is the region shaded? Okay, as you can see, it is on the right side of the line, and so right side means greater than. Okay, then we look at the type of line. We've got 2 types of line. We can have bolded lines like this, or we can have broken dotted lines like this. And if we have a bolded line, then that means all the points on the line are also part of the solutions. And so we have greater than or equal to. Alright. Therefore, the inequality for this region is x is greater or equal to 3. We just replace this equal sign and put this inequality sign, and now our equation changes to an inequality. Next, graph B. This time our line is a slopey one, so that means it has a gradient. So the equation of the straight line will come in the standard form of y equals mx plus c. So like the linear graph, we have to find these 2 things, the gradient and the y-intercept, and we plug it in to get our equation for the line. Okay, the easiest thing first, the y-intercept. It's right at positive 3. Okay, so the y-intercept c is positive 3. To get the gradient, we go rise over run. So we start from the bottom point here. We rise up, positive movement. We are going 1, 2, 3 steps up. So that's positive 3. And running to the second point, we are going 1 step, 2 step. So we are running to the right, which is a positive movement. So our gradient is a positive 3 over 2. And we plug them into the standard form. M is 3 over 2 x, and c is a positive 3. That's the equation of the straight line. Now we have to decide on the inequality sign to put in. So we look at the shaded region. By the look of the graph, it looks like the shaded region is on the left hand side. So if we think it's the left hand side, okay, then let's see. The shaded region is on the left, so the sign that we'll be choosing will be the less than sign. Less than sign. Okay, that means the inequality will be, okay, the sign will be less than, and because the line, the type of line is a dotted line, that means all the points on the line are not part of the equations, so there's no equal to sign. That means the sign that we are going to use is just less than sign. Therefore, our inequality will be y is less than 3x over 2 plus 3. Okay, let's proof check to see if our inequality is the correct one by doing a point test. So, to do a point test, you take a point on either side of the line and you plug it into the inequality. See if the inequality statement is true or false. If it's true, then the sign you chose is the correct one. If it's not true, then the other sign is the correct one. So let's see. Okay, I'm picking this point, negative 4, 0. That's this point right here, which is on the left hand side. It appears to be on the left hand side of the straight line, and we'll plug it into our inequality that we came up with. Y is less than 3x over 2 plus 3. Y is less than 3x over 2 plus 3. So x is negative 4 and y is 0. So let's substitute 0 into y and negative 4 into x. So here we have 0 is less than 3 times x, which is negative 4, dividing by 2 plus 3. We substitute 0 in place of y and negative 4 in place of x. So 3 times negative 4 is negative 12, dividing by 2 plus 3. So negative 12 dividing by 2 is negative 6, and negative 6 plus 3 is negative 3. And the statement says 0 is less than negative 3. 0 is here, and negative 3 is on the left hand side. So this statement is not true. Negative 3 is less than 0. So since this statement is false, that means the less than sign is not the correct one. Okay, it's not the correct one. The statement is false, so that means the less than sign is the incorrect one. So the greater than sign might work. Let's do another point test and proof check. So again, we substitute this same point, and this time we use the greater than sign to say that it is the shaded region is above the line. Above the line. This side is below and that side is above. So let's check. Okay, again 0 is y, negative 4 is x, so we plug it in place of x. So 3 times negative 4 over 2 plus 3 is negative 12 divided 2 plus 3. Negative 12 divided 2 is negative 6, and negative 6 plus 3 is negative 3 again. This time the statement is 0 is greater than negative 3. And that's true. And so the greater than sign is the correct one to use. And therefore we can change our signs. Okay. Now the shaded region is not to the left, but it is above the line. Okay, it's above the line, and therefore the correct sign to use is the greater than sign. Greater than sign. Okay, judging from the line, the type of line is a dotted or broken line, which means the points on the line are not part of the solutions. So that means we do not include greater or equal to, which is write greater than sign, and therefore our inequality for this graph is y is greater than 3x over 2 plus 3. So from this, we can see that when you have a vertical line, it is easy to say left or right. Or when we have a horizontal line, we can easily say top or bottom of the line. But when we have slopey lines like this one or like this one, then it's going to be a little confusing to say left side or right side or top or bottom. So a good thing is to do a point test where you pick a point on either side of the line, on the shaded part or the unshaded part, and you plug it in to the inequality that you think will work, and you check. If it's true, then the sign that you choose is the correct one. So that is it for this video. If you haven't subscribed yet, do so to get more updates and more videos on remedial questions. I'll be uploading until week 4 of term 4. So subscribe, press the notification bell to get notified of videos that are coming up. See you.